$13 billion. That is the price tag of the USS John F. Kennedy. For that kind of money, the American taxpayer expects a Death Star. But the first ship in this class was called a floating disaster. Broken elevators, faulty catapults, endless delays. The lead ship, the USS Ford, became a symbol of everything wrong with Pentagon spending. It left the public asking a brutal question. Why are we building another one? But here it is, CVN-79, the John F. Kennedy. It carries a legendary name, but it carries an even heavier burden: redemption. This ship was built to fix the mistakes, cut the costs, and prove that the American supercarrier is still the king of the ocean. So, did the Navy actually pull it off? Did they fix the glitches? Is this ship a 100,000-ton fortress, or just another expensive target in the age of hypersonic missiles? Today, we are not looking at a brochure. We are doing a battlefield audit. Let's step on deck. Chapter 1. The Floating City. If you stand on the pier and look up at CVN-79 from the waterline, the first thing you feel isn't power, it's scale. The human brain isn't wired to process objects this large. The bow rises like a steel cliff. The hull stretches longer than the Chrysler Building is tall, and the flight deck spans 4.5 acres of sovereign American territory. USS John F. Kennedy is a floating city in the most literal sense. It measures 1,092 feet from stem to stern. It displaces nearly 100,000 tons of water. You might picture it as an airfield, but an airfield doesn't move. This is an airfield built on a moving tectonic plate of steel, designed to endure hurricane-force winds, saltwater corrosion, and the sledgehammer impact of landing aircraft day after day for 50 years. And then there are the people. When fully deployed, you aren't just looking at a crew, you are looking at the population of a small American town. Nearly 5,000 souls: pilots, mechanics, engineers, doctors, police, and cooks. But unlike a normal town, this community operates with zero margin for error. A mistake of a few seconds on Main Street is a traffic jam. A mistake of a few seconds on this flight deck is a funeral. This ship demands a level of synchronization that most civilian industries can only dream of. Above the waterline, you see the jets. But the reality is that the flight deck is just the roof of a 25-story building lying on its side. Beneath your feet lies a labyrinth of aviation fuel tanks, munition magazines, server rooms, desalination plants, and hospitals. Miles of fiber optic cable and piping, everything required to keep a city alive before you even worry about keeping a warship fighting. But at the heart of this city, there is something more critical than the steel armor or the flight protocols: energy. CVN-79 is powered by 2 new-generation A1B nuclear reactors. But don't let the word nuclear distract you. The reactors are just the engine. The real story is the electricity. When the Navy says the Ford class is the electric generation, they aren't talking about light switches. They are talking about a fundamental shift in philosophy. A modern supercarrier doesn't just need power to move through the water. It needs power to think, to see, to track, and to sustain a combat rhythm that the previous generation simply physically could not match. This is where the average viewer gets it wrong. On an old Nimitz-class carrier, the wow factor was the size. On this ship, The wow factor is the ability to convert raw nuclear power into combat tempo. It's not just about carrying the air wing. It's about how fast you can process that air wing, speed of launch, speed of recovery, speed of rearming, and the speed of computing data. So why did the Navy spend $13 billion to build a new city instead of just updating the old one? Because the old city ran on steam. In the next chapter, we are going to witness the moment steam is officially kicked off the deck, and we will see why that single change is the difference between a ship built for the 1970s and a weapon built for the 2070s. Chapter 2: The Death of Steam. For nearly half a century, the United States Navy launched aircraft with a method that was as genius as it was violent: steam. For half a century, steam was the lifeblood of the American carrier. It powered the catapults. It ran the auxiliaries. It was powerful, reliable, and brutish. But steam has a limit. It requires heavy piping. It requires massive maintenance crews. And most importantly, it lacks precision. The USS John F. Kennedy was built to kill the steam age. It is a vessel designed to replace hydraulic brute force with digital precision, to replace pipes with wires, and to replace manpower with automation. If you have ever stood on the deck of a Nimitz-class carrier, you know the feeling. The deck shakes, steam vents hiss, and when the catapult fires, it hits the aircraft like a sledgehammer. It's a brute force solution. It works, but it has a ceiling. And in the eyes of the Pentagon, steam has finally hit that ceiling. Think about it. A steam catapult is basically a massive pressure cooker buried under the flight deck. It requires miles of high-pressure piping, heavy valves, and an army of mechanics to prevent leaks. But the real problem isn't maintenance, it's physics. Steam is hard to tune. You are essentially using a controlled explosion to throw a plane. That violent shock puts massive stress on the airframes, shortening the life of multi-million-dollar jets. And more importantly, steam struggles with the future. It's too strong for the lightweight drones of tomorrow, and it's struggling to push the heavy, fuel-loaded fighters of today to their limit. Enter the revolution, or as the critics called it for years, the problem. EMALS, the Electromagnetic Aircraft Launch System. CVN-79 has ripped out the plumbing and replaced it with magnets. Instead of a steam piston, the Kennedy uses a linear induction motor. It's the same technology you see in high-speed maglev trains or the most advanced roller coasters. Instead of a sledgehammer blow, EMALS grabs the aircraft and accelerates it along a precise, software-controlled curve. It takes a 30-ton fighter from 0 to 165 miles per hour in 3 seconds. But it does it smoothly. This matters. Less stress on the jet means less maintenance. Precise control means you can launch a heavy F-35C 1 minute and a lightweight surveillance drone the next, just by typing a new weight into the console. Steam could never do that. But launching is only half the battle. You also have to catch them. This is where the AAG comes in, the Advanced Arresting Gear. On older ships, catching a landing plane was done with hydraulics. Again, heavy, messy, and hard to adjust. The Kennedy uses a turbo-electric engine to absorb the energy of the landing. It's essentially a giant shock absorber made of software and electricity. Now, we have to address the elephant in the room. On the first ship, the USS Ford, these systems were a nightmare. They broke down, they failed reliability tests, they became the punchline of complexity of naval jokes. So, is the Kennedy just inheriting a broken system? The Navy says no, and here is why. In shipbuilding, Ship 1 is where you find the problems. Ship 2 is where you implement the solutions. The builders of the Kennedy had the benefit of thousands of hours of failure data from the Ford. They didn't just install the same machines, they installed the lessons learned. Software patches, hardware tweaks, better installation crews. The goal for CVN-79 is to hit the magic number, a 33% increase in sortie generation rate over the Nimitz class. That is the metric that justifies the $13 billion. If this electric system works, the Kennedy can turn planes around faster, launch them more frequently, and keep the pressure on the enemy longer than any steamship ever could. This chapter isn't just about switching fuel sources. It is about turning the flight deck from a mechanical workshop into a digital factory. We have moved from the age of the mechanic to the age of the technician. But a factory is useless if it doesn't have a product. And the product of this ship is the most advanced air wing in history. In the next chapter, we are going to look at the invisible fist. Because for the first time, a carrier has been built from the keel up to speak the native language of the F-35. Chapter 3. The Invisible Fist. If you have walked through chapters 1 and 2, you understand the machine. Now, we need to talk about the mission. Because a carrier, no matter how advanced, is just a floating airport. It is useless without the planes. But CVN-79 wasn't just built to carry planes. It was built to serve as the nerve center for a new kind of aerial warfare. For 50 years, carrier doctrine was simple: fly out, drop bombs, fly back. The John F. Kennedy is designed for a different reality: the network. This is the first ship in the fleet built from the keel up to be native to the F-35C Lightning II. On older Nimitz-class ships, integrating the F-35 was a retrofit, a struggle to upgrade classified spaces and data cables. On the Kennedy, the ship speaks the language of the 5th generation right out of the box. The F-35C isn't just a stealth fighter, it is a flying sensor node. Through sensor fusion, it sucks in radar data, thermal imagery, and electronic signals, stitches them into a single clear picture, and beams that data back to the ship and the rest of the fleet. This changes the role of the carrier. The Kennedy isn't just launching airstrikes, it is launching an intelligence network that can see over the horizon. But seeing isn't enough. You have to be able to hit. And in the Pacific, the biggest problem is distance. Competitor nations have spent decades building carrier killer missiles designed to push the U.S. Navy away from their shores. They want to force the carrier to stay out of range. The Kennedy's answer to that problem is the MQ-25 Stingray. To the casual observer, it's just an unmanned drone. To a strategist, it is a game changer. It is an aerial tanker that can extend the combat radius of the air wing by hundreds of miles. With the MQ-25, the Kennedy can park safely outside the enemy's kill zone and still deliver a stealthy F-35 strike deep into hostile territory. It turns a defensive problem into an offensive advantage. But all this high-tech wizardry fails if you can't arm the jets fast enough. This brings us to the most unglamorous yet critical upgrade on the ship: the advanced weapons elevators. On the old ships, moving bombs from the magazines deep in the belly up to the flight deck was a slow, cable-driven process. It was a bottleneck. The Kennedy uses electromagnetic elevators, fast, automated, and capable of moving 24,000 pounds of ordnance at 150 feet per minute. Why does this matter? Because of sortie generation rate. In a high-intensity fight, the winner isn't the one with the best plane. It's the one who can land, refuel, rearm, and launch again the fastest. Think of the flight deck as a Formula One pit lane. The Kennedy is designed to be the fastest pit crew on the ocean. So, when you look at the deck of CVN-79, don't just see a runway, see it for what it really is, a factory. A factory that produces violence at a rhythm and speed that no other nation can currently match. It merges the stealth of the F-35, the reach of the MQ-25, and the speed of electric logistics into a single, invisible fist. But a fist is only as good as the stamina behind it. How long can this ship keep fighting? How long will this technology stay relevant? In the next chapter, we look at the biggest gamble of all, the 50-year bet. Because the Navy didn't build this ship for the War of 2026. They built it for the War of 2076. Chapter 4: The 50-Year Bet. There is a simple way to understand the USS John F. Kennedy. Don't look at it as a ship. Look at it as a time capsule. When the U.S. Navy signs a check for a Ford-class carrier, they aren't buying a product for this decade. They are buying a sovereign airfield that has to remain relevant until the 2070s. That is a terrifying engineering challenge. How do you build a weapon today that can survive a war 50 years from now against enemies that haven't even been born yet? You do it by making a massive bet, the 50-year bet. The first part of the bet is electrical margin. History has taught the Navy a brutal lesson. Ships usually don't retire because their hulls wear out. They retire because they run out of juice. They run out of the space and power needed to install new radars, new computers, and new defenses. The Kennedy was designed to avoid that death. Thanks to those A-1B reactors, this ship generates 3 times the electrical capacity of the Nimitz class. Right now, in 2025, that is overkill. But the Navy isn't planning for now. They are leaving that power grid open for the future. Directed energy weapons, high-powered lasers to shoot down hypersonic missiles, massive electronic warfare suites. The Kennedy is essentially a giant floating battery, waiting for the weapons of the future to be plugged in. The second part of the bet is the industrial base. This is the part that doesn't make the headlines, but it keeps admirals awake at night. Building a nuclear supercarrier is the most complex industrial task on the planet. It requires a supply chain of thousands of companies and a workforce of highly specialized shipbuilders at Newport News. If you stop building them, that workforce disappears. The skills rust, the supply chain breaks, and once you lose the ability to build giants, you might never get it back. So CVN-79 isn't just a warship, it is a life support system for the American naval industrial complex. It proves that the United States can still do the one thing its competitors are desperate to copy: build these monsters at scale. But a bet is still a gamble, and there is risk. Critics argue that putting $13 billion into one hull is putting too many eggs in one basket. They point to hypersonic missiles. They point to drone swarms. They say the age of the carrier is over. The Navy's counter-argument is simple: adaptability. A silo-based missile can't move. An airbase on land can't move. The Kennedy can move 700 miles in a single day. It can change its air wing from manned fighters to drone swarms. It can upgrade its defenses. It is a bet that mobility and upgradability will always beat a static target. But technology and strategy are only cold calculations. At the end of the day, a ship is just steel until it has a soul. And that brings us to the final chapter. Why name it John F. Kennedy? Because in the world of geopolitics, you don't just need a weapon that works, you need a symbol that resonates. When this ship appears on the horizon, it sends a message that no email, no diplomat, and no sanction can ever match. In the final chapter, we look at the return of the king. Presence. Because 100,000 tons of diplomacy is about to arrive. Chapter 5: The Return of the King. War isn't always a spreadsheet. You can count missiles, you can compute sortie rates, you can track the billions, but you can't quantify a feeling: presence. In the world of geopolitics, presence is the currency of power. A strongly worded email doesn't stop a blockade. A press conference doesn't open a shipping lane, but a nuclear supercarrier does. This is why the United States continues to build these giants, despite the cost, despite the critics, and despite the risks. Because there are moments in history where diplomacy fails, and the only thing that resets the board is 100,000 tons of American steel cutting through the horizon. You cannot deploy a virtual airbase to a crisis zone. You need something real, something heavy, something that brings its own gravity. And the USS John F. Kennedy carries a gravity heavier than most nations. It carries a legacy. The name Kennedy isn't just paint on the stern. It is a reminder of an era when America believed it could do the impossible, whether that was going to the moon or standing down a nuclear superpower. This ship is the physical embodiment of that mindset. It is a statement that says, we are still here, and we can still build the things that no one else can. But the true strength of this ship isn't the email's magnets or the A-1B reactors. It's the crew. We talked about the floating city in Chapter 1. But cities are defined by their citizens. When the Kennedy deploys, it is powered by 5,000 sailors. Most of them are barely in their 20s. They are the ones who make the audit pass or fail. A carrier doesn't survive on specifications. It survives on discipline. It survives on the deck crew working in freezing rain, the reactor techs monitoring the core at 3 a.m., and the pilots trusting the catapult with their lives. That human factor is the one variable our competitors have yet to replicate. So let's go back to the $13 billion question we asked at the start. Is the CVN-79 a waste of money? Is it a floating target? Maybe. In a total war, nothing is invincible. Even a giant can bleed. But look at the alternative. Without it, the ocean becomes a much larger, darker place. Without it, you lose the option to act. The Kennedy wasn't built to be invincible. It was built to be undeniable. It is a floating guarantee that when the world gets dangerous, the United States has the option to change the outcome. The USS John F. Kennedy enters the fleet not just as a warship, but as an answer to the failures of the USS Ford, an answer to the rise of peer competitors, and an answer to the critics who say the age of the carrier is over. It is big, it is expensive, it is controversial. But as long as the oceans connect the world, the king is not ready to give up his throne. So here is the question for you to decide. In the age of hypersonic missiles, is the supercarrier still the ultimate symbol of power, or is it just the ultimate target? Let me know what you think in the comments. This is Future War Tech, signing off.